good afternoon, or good morning. Welcome to today's webinar, Tackling Carbon Complexity, a Manufacturer's Guide to Effective Carbon Tracking. My name is Anna Chong-Pinichai. I'm the Senior Director of Strategic Partnerships at the NAM, and I am pleased to welcome Yoram Burnett to today's webinar. Yoram is the CTO and the founder of Scope 5 Software, which is part of Environ Energy, our partner for NAM Energy. Yoram boasts a 40-year career in high tech with notable periods at AT&T, Bell Labs, and Microsoft. In 2009, he shifted his focus to sustainability and founded Scope 5, which is the software platform used by leading companies to monitor sustainability performance, report to stakeholders, reduce emissions and costs, and increase resource efficiency. Scope 5, as I mentioned, was acquired by Environ Energy, where Yoram continues to advance the product forward as the CTO. Really excited to welcome Yoram to our group here, as his background is in electrical and biomedical engineering, and he has written many articles, papers, and speaks regularly on sustainability and technology topics. So without further ado, Yoram, welcome, thank you, and I now turn it over to you.
Anna, thank you. It's an honor to be here today. I'm excited to share a little bit of what I've learned over the years helping organizations track their carbon or greenhouse gas emissions. I'm going to talk about GHG emissions and why they matter. I'm going to spend some time introducing a protocol and taxonomy. I'm going to talk about a cycle of measuring, quantifying, and reporting, all in the interest of optimizing operations and reducing waste. And then I'll spend a few minutes on advanced work. Now, I recognize that there might be a broad range of maturity and carbon tracking savviness here, so I might be boring some of you at times. I might be challenging you, some of you at times. If so, forgive me. My email is on the first and last slide, and I'm happy to take questions after the session and over email going forward. So first, what are these GHG emissions? GHG stands for greenhouse gas. There are many greenhouse gases. The most common one is carbon dioxide, which is why we often, it's a misnomer, call greenhouse gas emissions just carbon emissions. Each of these gases has a global warming potential. Carbon is the standard with a GWP of 1, and all the other greenhouse gases are compared to it with a number that indicates their relative potency as greenhouse gases. So at the other end of the extreme is sulfur hexafluoride with a GWP of 23,500. Often you'll hear GHG emissions quantified as carbon dioxide equivalent. And what's happening here is someone is taking the set of greenhouse gases that are emitted by some activity or organization, taking each one of those gases, measuring its weight, multiplying that weight by that gas's global warming potential, and then summing those products to get the total carbon dioxide equivalent, or how many tons of carbon dioxide these total emissions would be equivalent to. Now, why do these matter? Well, the common answer is global warming. No matter how you feel about global warming, it's indisputable that regulatory pressure and fines are increasing, and they're going to continue to increase. We can anticipate fees, carbon taxes, and cap and trade to proliferate. At present, the entire west coast of North America is under one or another form of carbon tax or carbon trading program. Stakeholders are asking. Our first client came to us because one of their supply chain customers asked them to quantify their carbon emissions in order to remain a vendor in good standing. Walmart asked some 100,000 vendors to quantify their carbon emissions each year. What may be most interesting here is that carbon is a good proxy for waste. If you're managing carbon, you are identifying sources of waste and opportunities for efficiency. For all these reasons, paying attention to greenhouse gas emissions is just smart business. Now, these are a few quotes. These quotes substantiate the premises I just raised. There are a dime a dozen. You can find these quotes all over the internet. I'm not going to spend time reading them. I just wanted to share some of them here. You can see them in the slides. I'm going to speak about a virtuous cycle here. We all want to improve our bottom line. One way to do that is to reduce waste. One way to reduce waste is to manage emissions. If we want to manage emissions, we need to measure them. If we report, and commit to targets. That compels us to measure, and then we can get in this virtuous cycle of measuring and managing our carbon emissions and reducing waste and improving our bottom line. Okay, I'm going to introduce a protocol and a taxonomy. Everything I talk about here is going to be based on the greenhouse gas protocol. It's a global standard. It's a no-brainer. It's pretty simple. They have loads of publications. That's the way we measure greenhouse gas emissions. I'm going to introduce a taxonomy. Well, I didn't make this up. This is a taxonomy in the industry. And what I want you to think about here is start thinking about all the activities that, as a manufacturing organization, that you engage in. And one way to arrive at that set of activities is to think of four activity types: stationary combustion, mobile combustion, electricity, and fugitive emissions. And one way to think about those is to think about all the energy, all the ways in which your organization uses energy. Those include activities such as the first three: stationary combustion, mobile combustion, and electricity. And then think about all the processes in which your organization engages. Those are where your fugitive emissions activities are likely to be found. Another taxonomy piece is the scope. I will talk about scopes a little later on. For now, we're going to focus on activities. So in the context of the energy you use, I spoke about stationary combustion, mobile combustion, and electricity. Stationary combustion is any activity that combusts fossil fuels in machines that don't move. So as a manufacturing organization, you probably have furnaces and boilers and other machines that don't move, that combust fuels. Think about your brick and mortar manufacturing facilities. What machines are combusting fossil fuels there? What tanks do you have? There's that old oil tank in the corner, that diesel tank, that compressed natural gas tank, a propane tank. All of those are going to shed light on your sources of stationary combustion. Next is mobile combustion. Mobile combustion activities are those activities that combust fossil fuels in machines that do move. So think of driving, flying, freight, forklifts. For this, you have to think beyond your facility. How do materials arrive at your facility, leave your facility? How do your employees get to work? Do you hop on a plane for business travel? All of those are mobile combustion. Forklifts are interesting. They're kind of an anomaly in that they often stay in the brick and mortar facilities, but if they're not electric, they're probably also a source of mobile combustion. Okay, the third category of activity under energy is electricity consumption. Electricity is used for a bunch of applications in manufacturing, obviously. The interesting thing about electricity is that it doesn't directly emit greenhouse gases, but somebody somewhere is probably combusting fuels to provide you with that electricity. And that amount the amount of emissions from those fuels can be quantified by the amount of electricity you use. The amount of emissions per kilowatt hour or megawatt hour will vary from electricity grid to electricity grid or provider to provider. That quantity is something that you are indirectly but quantifiably responsible for as a manufacturing organization. There's another activity that comes under energy that is much less common than electricity, stationary combustion, and mobile combustion, but still important more frequently in manufacturing organizations. And those are steam, heat, and chilled water. They're similar to electricity in that if somebody else is providing them, you're not generating the emissions, but you are responsible for a quantifiable amount of emissions that are generated in order to provide you that energy in the form of steam, heat, or chilled water. Now, this is a Sankey diagram. I love Sankey diagrams. And this is manufacturing across the US for 1 year. If you look all the way at the right, it shows that the total manufacturing emissions across the US, I think this was from 2018, modified in 2022. If you look at the right, you see the number there is 1,164.9 total GHG emissions. That's actually millions of tons of CO2. So that's about 1,200 or 1.2 billion tons of CO2 emissions, total US manufacturing emissions per year, on that order. Now, if you look all the way at the left, you see these various energy sources and how they flow in to generate those emissions. So a biggie is the red band all the way at the left. That's electricity. An even bigger one are those combinations of yellow bands. Those are various fossil fuels. Steam is that small blue band at the bottom. And there's probably some chilled water, but probably too small to show on this diagram. If you move to the right, you see that some part of those, a small part of those energy sources flow into generating electricity and operating conventional boilers on site. The vast majority flows into process heating, machine drive, cooling, refrigeration, other electrochemical processes, electrolysis, electroplating. There's a dark purple band there that is process emissions, which really accounts for fugitive emissions that may not directly be a result of the energy coming in, but they are part of that the operations driven by that energy input. Finally, at the bottom is a fairly narrow purple band showing that some energy goes into overhead like heating and cooling a facility, on-site transportation, and similar. Okay, so that dark purple band, that's process emissions. Remember, I said we want to look at our activities. We're trying to identify all our activities. We're going to look through two lenses: energy and process. And so the energy emissions are typically going to be carbon dioxide primarily, and then a couple of gases, greenhouse gases that often accompany carbon dioxide. Those are methane with a GWP in the low 20s and nitrous oxide with a GWP in the low 300s. Those go with energy, with combustion of fossil fuels. When we start to look at process emissions, which will indicate all our fugitive emissions, those are much more industry specific. And there's some really esoteric gases in there with high global warming potentials. And especially as manufacturing organizations, you'll probably want to pay a lot of attention to your process emissions. So, for example, if you're in the business of producing cement, there's a lot of carbon dioxide emitted when limestone goes into a kiln to produce clinker. If you're steel making, then reducing iron ore generates a lot of carbon emissions. It's just part of the process, inescapably. If you're in the business of chemical manufacturing, you will have leaks of greenhouse gases in the form of various chemicals. If you are aluminum smelting, perfluorocarbons from electrolysis are a high global warming potential. Sulfur hexafluoride, that big one we looked at right at the beginning, that's used in high voltage electrical power equipment that leaks and decays over time. It's also used in etching semiconductors, PV panels, and similar products. More fugitive emissions that come under processes. If you're in the oil and gas industry, you're probably leaking methane. If you're manufacturing glass, fluorinated gases, that's sulfur hexafluoride again, and nitrogen trifluoride, high global warming potential. If you have any piles of waste sitting around, organic waste, they're probably emitting methane and nitrous oxide. Those are all kind of fugitive emissions from various processes that might be unique to your industry. I'll mention refrigeration here. Some of that will be processed. Some of that will be just our knowledge-based companies that run offices with air conditioners, use air conditioners. Those refrigerants, all those refrigerants are hydrofluorocarbons. They leak out of the air conditioners or the compressors, condensers, and they are high potency greenhouse gases. Okay, let's talk about how we quantify the emissions from all these activities. So the IPCC and the Greenhouse Gas Protocol have recognized three measurement tiers. Tier 1 is based on gross averages. So tier 1 you would be reporting under tier 1 if you said, well, I'm going to look up on the internet what the average emissions per year for a manufacturing plant in the US is, and I'll use that number. So it gives you a number, but it doesn't give you any insight to your operations. So we're not going to spend a lot of time on tier 1. Tier two is where we'll spend most of our focus. Tier two talks about the idea of tier two is that you quantify your activities, and each activity has an associated emissions factor. Now, there are commonly available, publicly available tables and tables of emissions factors that take the form of, for example, 19.54 pounds of carbon dioxide equivalent per gallon of gasoline. So if you are quantifying your activity in some units appropriate for that activity, you can probably get your hands on emissions factors that can be used to convert that activity to emissions. These emissions factors are available from the EPA, the IPCC, DEFRA, the Climate Registry, the Greenhouse Gas Protocol, and more and more. You also might put together some simple models that are based on those emissions factors that are suitable for your activity type, for how you measure activity. Now, I want to make an important point here, which is that all of these are models. Most of these are models and estimates. We are not going to obsess with precision here. Mainly, we're doing this exercises so that we can compare greenhouse gases from one activity to another, and over time do longitudinal studies and make sure that we are driving efficiency and improvement. So that's tier two. Tier three is rarely used by our knowledge base clients, but very frequently used by our manufacturing organizations, especially ones that have high greenhouse gas emissions. Tier three involves direct measurement with continuous emissions monitoring systems, such as in cement smokestacks, etc., or highly complex emissions factors modeled based on some precursor activity data. And tier three is where it gets interesting. We'll touch on it here. We're not going to spend a lot of time on it here because it is so application specific. Okay, so let's look at some examples. For calculating your electricity emissions, you would collect activity data in the form of megawatt hours, kilowatt hours. In the form of energy, you have those numbers on your utility bills, on meters at your facilities, and then there are commonly available tables of emissions factors. They're usually specific to a certain grid location. There are 17 or so grids in the US, or even better, they are produced by individual electricity providers, and they're just the form of so many pounds of CO2 equivalent per kilowatt hour. And those emissions, again, all these emissions that come under energy are primarily carbon dioxide, methane, and nitrous oxide. Stationary combustion, that's typically the activity will be measured in volumes of fuels of certain types of fuels like gasoline or diesel or compressed natural gas. Some stationary combustion is measured in energy, such as therms of natural gas. Most tables will give you conversion factors from both energy and from volume, or emissions factors from either unit. Now, mobile combustion is it's similar to stationary combustion, but it's a little more complicated. In the case of stationary combustion, the amount of carbon dioxide, the amount of methane and nitrous oxide emitted alongside the carbon dioxide doesn't vary hugely. It's not a lot, that they are smaller amounts than the carbon dioxide, but because they're high global warming or higher global warming potential, they're worth considering. But when we look at mobile combustion, the distance driven in the engine and the particular engine type will impact the amount of methane and nitrous oxide emitted, whereas the amount of carbon dioxide emitted is primarily dependent on the fuel volume. So if you really want to, if you are seeking precision in mobile combustion, which might be appropriate if your primary product is fleet related, if that's a big part of your combustions, of your activity, then you will want to consider more activity data besides just fuel volume, such as distance driven and what the engine type it was driven in. Fugitive emissions, those are In many cases, they're already measured. If we're looking at the most common fugitive emissions we work with clients with is refrigerant leakages. And in those cases, the mechanic comes and tops up your condenser. If they say, "Up, I put in 4 pounds of R404," that represents that is, they are feeding you directly the amount of emissions. You don't need to convert, you don't need an emissions factor. You just take those 4 pounds, multiply it by the global warming potential of R404, and there you have it, carbon dioxide equivalent. But many industrial processes for their fugitive emissions require modeling. So, for example, we worked with a semiconductor manufacturer that used sulfur hexafluoride to clean semiconductors, to etch semiconductors. And in that case, they came up with a model that quantifies emissions of sulfur hexafluoride per wafer or per ingot. And so that model would be appropriate for their activity, few other activities. So in the case of fugitive emissions in manufacturing organizations, there's a lot of specificity and individualized emissions factors generated. Data collection and maintenance. So remember, I'm talking about this virtual cycle of measuring and managing in order to reduce. And in order to we want this to be a sustainable activity. In order for this to be sustainable, you're going to have to come up with a data maintenance plan that is not terribly burdensome. It's a big part of any sustainability work, and greenhouse gas emissions calculation and management in particular is collecting all that activity data. So let me give you an example. If you're working with mobile combustion, we have had many customers over the years for which mobile combustion is part of their activity. It's not the dominant part of their activity. And they don't have commonly available to them typically fuel volume. They do have commonly available to them fuel distance, but the majority of mobile combustion emissions are a function of fuel volume, not fuel distance. So what are they going to do? Well, they could incur the really expensive, burdensome process of starting to collect fuel volume, but for them, fuel distance driven is commonly available from odometer readings. So what they do is they estimate an average fuel efficiency for their fleet and multiply the distance driven, which is a commonly available metric, times that average fuel efficiency to come up with their fuel volume for each type of fuel. And then they can use commonly available emissions factors to convert that fuel volume to emissions. Now, you might say that, well, calculating an average fuel efficiency for a whole fleet is pretty sloppy. Well, yeah, you could go for more granularity. You could divide your fleet into fuel efficient vehicles, fuel intensive vehicles, and middle of the range vehicles. And you could come up with, you could get the odometer reading for total vehicles in each sub-fleet, and then you could multiply those numbers by the emissions factors. But you could use fuel efficiency numbers for each portion of the fleet and multiply those to get the volumes of fuel of each type that you would then multiply by fuel emissions factors. So what we've done there, we've done two things. We've looked at being flexible with the units in which you collect your activity data on the one hand, and also seeking more granularity on the other. So if you're going with subfleets and 3 fuel efficiency numbers, you have more data to manage. It's a little more burdensome, but you also enable more insight and more accuracy. All of this should be iterated on, thought about up front, and continually iterated on. What kind of data is available to you? What emissions factor models will you use to convert that data? How are you going to maintain that data on a regular basis? Okay, I'm going to talk about reporting. The EPA mandates generally that any facility emitting over 25,000 tons of carbon dioxide equivalent per year must report. I suspect that a large portion of you probably do have facilities that fall under that regimen, and a large portion of you probably have smaller facilities. Senate Bill 253 in California is based on revenues. Any company doing over $1 billion of revenue in California must report. There's an EU carbon border tariff coming in a couple of years. That's going to be another reporting burden. There are miscellaneous cap and trade programs. In Washington, we just passed a cap and invest program that requires companies to report. It doesn't, whether you are currently under a reporting regimen or not, it's a good idea to prepare for it. It's likely that these will get more onerous. And even if you start by reporting internally or doing this for your CSR reports, you're starting to get in that discipline of measuring and managing to reduce waste and improve the bottom line. Okay, remember I spoke about scopes and I said I'd come back to those when I spoke about reporting. So this slide is right out of the Greenhouse Gas Protocol's one of their standards. Across the top are a series of, first, the three common greenhouse gases, carbon dioxide, methane, and nitrous oxide. And then there's hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride, all really high global warming potential gases or groups of gases. But I really want you to focus on these four arrows here. Note there that middle arrow is scope 1. All the way at the left, we have an arrow called scope 2, and then we have two scope 3 arrows. One to the left represents emissions incurred by any emitting activity that touches your product's supply chain. So from the extraction of raw materials to the delivery to your gate, those are your upstream scope 3 emissions. On the right, we have your downstream scope 3 emissions. So any emitting activities that touch products that you manufacture from the moment they leave your gate until their end of life treatment, those are your downstream scope 3 emissions. When you report, you need to report you need to designate emissions as being under one or another scope. Now, most reporting regulations require scope 1 and scope 2. Scope 3 is still largely optional, but not always. It's a lot more complicated given that it's a lot farther reaching. Scope 1 refers to emissions from activities that emit on your facilities. So boiler and furnaces are obvious, they're in your brick and mortar facility. Trucks, if you own or operate them, are your facilities also, even though they're mobile. Scope 2 emissions are from activities that you're quantifiably responsible for their emissions, but they're not emissions happening on your premises. And the examples we gave were electricity, steam heat, and chilled water. Finally, scope 3 emissions are everything else upstream and downstream. Think of how do employees get to your offices? Do you ever hop on business travel? Those are scope 3 emissions related to mobile combustion. How is waste handled? How are do you recycle your products? Where do your raw materials come from? Those are all your upstream and downstream scope 3 emissions. Now, when you report, you'll declare that you're reporting under a certain organizational boundary, operational or financial. I'll leave equity share alone for the moment. Operational, if you say that I'm reporting under operational control, that means that any emitting machines that you operate are your scope 1 emissions or scope 2 emissions. If somebody else operates them, those are your scope 3 emissions. If you're reporting under financial control, then any machines that you own are your scope 1 and scope 2 emissions. If those machines are owned by others, then those are your scope 3 emissions. So to summarize measuring and reporting, we started with a way to identify all material activities, thinking of energy used and processes, and then under energy used, think of mobile combustion, stationary combustion, fugitive emissions, mobile combustion, stationary combustion, electricity, steam heat, and chilled water. And then under process, we thought about primarily fugitive emissions and the various specific ones that are unique to different industries. We spoke about identifying about how we're going to quantify those activities and what emissions models and factors we'll use to calculate the emissions they generate. We spoke about putting together a data collection and maintenance plan. Highly recommend selecting some carbon accounting software. You can get away with doing this in Excel for a little bit, but it'll make it really hard to get the benefits that you get out of the analytics available in good carbon accounting programs, and it'll be very hard to do longitudinal studies when Joe, who's maintaining that spreadsheet for 10 years, suddenly leaves and you have to do it differently at this point. And you're trying to compare numbers over time. Recommend dedicating human resources to the program and identify those reporting authorities and programs that are going to motivate you to do this measurement and management. Let's talk about reducing. Start with scope 1 and scope 2. At scope 3 there are opportunities there, some of them quite easy, but it is so much more complicated. And scope 1 and scope 2 are closest to home and you have most direct control over them. Identify low-hanging fruit first. You will all probably find plenty of low-hanging fruit. Renewable energy certificates is one such low-hanging fruit. They're kind of a get-out-of-jail-free card. Actually reducing emissions is even better. Part of that is going to be via abatement. For manufacturing, abatement options aren't available to many knowledge-based companies. But for manufacturing organizations, if you're large enough, you probably already have some kind of carbon capture and alternative use and storage. Different if you're reducing steel, you can maybe use hydrogen. These are all sorts of pretty advanced ways of moving forward with abatement. If you're using sulfur hexafluoride, you want to capture and recycle as much as possible. Often it turns out many clients we work with are just using chemicals for which there are equally functional, lower global warming potential alternatives, and often those are even less expensive. A lot of that has already been done for refrigerants, but there are many chemicals for which this can still be applied. And finally, use intensity metrics. I'll speak to that shortly. So these RECs I spoke about, remember that red band at the top of the Sankey diagram? Electricity is a big part of manufacturing carbon emissions, greenhouse gas emissions. See, now I'm using that misnomer. Electricity is a big part of greenhouse gas emissions. You can purchase RECs. It doesn't actually reduce your electricity use or even your electricity emissions, but what is happening is you are, through your purchase of RECs, you are funding the development of low or zero emissions electricity generating infrastructure somewhere else, potentially with your provider, but typically somewhere else, and you get credit for those emissions-free electrons that will be generated. Now, those are carefully tracked and retired, so there's no double counting here, but RECs are a great type of low-hanging fruit. Typically, companies we work with do all the reduction and abatement they can. Where they can't, they buy RECs. RECs meet some reporting protocol and regulatory requirements, not others. Ideally, though, you actually want to reduce energy and emissions. So electrify where possible. Machines that use fossil fuels will always emit greenhouse gas emissions. Machines that are electric will only emit greenhouse gas emissions to the degree that the electricity they use is emissions intensive. Electricity increasingly is becoming available in lower emissions form. So by electrifying machines, you are future-proofing and taking advantage of opportunities where you can get low emissions electricity. Purchase low or zero emissions electricity, whether that's through purchase power agreements or RECs or various direct lines, various mechanisms you can purchase low or zero emissions electricity. Generate electricity on site, solar, wind, cogen. We had a wastewater treatment plant who would flare methane. Now they combust their methane to generate energy to drive other machines. Waste to energy, great option for some organizations. Insulate those furnaces. Whatever heat you can't keep in, use that heat for cogen to generate electricity to drive other machines. And then this one's kind of esoteric, pretty advanced. So electricity grids that have significant amounts of renewables feeding into them, or any electricity grid, tends to vary. Their emissions factor tends to vary hour by hour as the climate changes, as the weather changes, for instance, as people come home and leave for work. And some of these grids make available signals that indicate whether they are at a low emit, what their emissions at the moment are per kilowatt hour or megawatt hour. And advanced companies can use these signals to control when they are pulling electricity from the grid. Obviously, you want to pull when the mix of fuels is low emissions intensity. Abate where possible, carbon capture and sequestration. Again, this is a luxury available to some big manufacturers, not to our knowledge-based companies or smaller companies. You want to switch to cleaner fuels where possible. Coal is by far the dirtiest. Scrubbers and abatement systems specific for your industrial processes. We worked with a semiconductor that used an abatement system for sulfur hexafluoride, and we helped model that. Switch process chemicals. Look for opportunities to use lower GWP chemicals. Apply fine grain analytics and set targets. So remember I spoke about that kind of tier one measurement where you just come up with this one number. Oh, here's my emissions for the year. That's not very fine grain. That's coarse grain. There's no slicing and dicing that can be done there. The opposite extreme of that is going very fine grain and being able to slice your data both spatially and temporally. So for example, to be able to say, oh, my emissions in Indiana are more than my emissions in Illinois, being able to compare your emissions from your mobile combustion sources to your stationary combustion sources, or from some subfleet to another subfleet, or one stationary combustion facility to another stationary combustion facility. All of those are forms of spatial granularity. Temporal granularity is being able to, for example, compare your emissions by day versus your emissions by night, or your emissions during the summer to your emissions during the winter. Now, this increasing granularity increases the complexity of the work you're doing, the complexity of data collection, and so it has some burden, but it also surfaces opportunities for improvement. That's where you're going to find the opportunities to reduce waste. So you want to seek a balance between especially in your data collection, you're going to want to seek a balance between granularity and on the one hand, and burdensome of data collection on the other. Normalize. So we all are compelled by our shareholders to grow year on year, to manufacture more year on year. We're all subject to business cycles. We want to be able to, it's important to be able to separate changes in our emissions that occur as a result of changes or improvements in practices from those that result from changes in business cycles. So for this reason, we normalize. It's one thing to say my emissions were 1,000 tons for the year, but it's a different thing. It's better to be able to also say my emissions are 1 pound per square foot, or 1 pound per widget produced, or half a pound per dollar of revenue. These intensity metrics will both help surface opportunities for improvement, and they will point you to those parameters of your activities to which your emissions are most sensitive. Set targets and monitor progress. So there's a lot of hoopla around science-based targets. Those are complex and quite valuable, but it doesn't have to be science-based targets. Just set some targets. You can announce them publicly, you can set them internally and not announce them publicly, but having targets and monitoring progress against you will help you stay in that virtuous cycle of measuring, managing, and reducing waste, and continually iterate. Am I reaching my targets? Why not? Use fine grain analytics and fine granularity to see why not, and then you know what to fix in order to stay on target. Okay, I'm going to spend a few minutes on some advanced work we've been doing with some of our clients over the years. I invite any of you who are interested to reach out to me. We'd love to have some partners on this. My email is on the first and last slide in this presentation. So I'm going to talk about emissions per widget. Have you ever been asked by a supply chain customer to quantify the emissions per unit for some product they're purchasing from you? We've seen both sides of this. We have manufacturing clients who have said, I've been asked to quantify my emissions for a particular product. Can you help me? And we've had supply chain clients who reach out to us to say, I'm trying to improve my scope 3 inventory, and I want to get from my tier 1 providers emissions per widget. Can you help? Now, if you're manufacturing just one type of widget, that can be easy to do. You manufacture 1,000 widgets per year, you got 1,000 tons of emissions, that's 1 ton per widget. But most of you probably manufacture a variety of widgets or a variety of product lines, and that can be really hard to do. Today, that's commonly done based on a product's physical or economic factors. We work a lot with clients to apply a US extended economic input output model to assign emissions to products based on their cost. Those are full life cycles as opposed to just tier 1. They give you a number. It has some utilities, but it's a pretty crude approximation. There are better ways to quantify per widget emissions. And this is right out of the greenhouse gas protocol. That center column there kind of shows in descending order of preferability how you would quantify per widget emissions. At the top there, they're imagining that you just have that number somehow. The example of if you manufacture one widget, it's pretty easy to get, that might fall there. All the way at the bottom is that practice of just, well, I'll do it based on cost, which is a crude approximation. I want to focus on those two red lines in the middle. The top one says, well, how about submetering and using detailed models to kind of synthesize emissions per widget from your production lines. And the next one says somewhat teasingly and vaguely, well, just use an engineering model. So I'm going to spend a minute on those two. The fine-grained submetering, that's great, and it might have other benefits, but it typically requires a lot of instrumentation to be installed and maintained and the data from it to be processed, and that can be quite expensive and cumbersome. We've used a statistical engineering model to great advantage. It's a lot simpler than submetering. It accounts for all sorts of overhead that might otherwise be missed or hard to measure. And as a bonus, it alerts us when we have sudden changes in our product, in our process efficiency. It's a top-down black box approach. It entails putting together a set of simultaneous equations, and each equation is quite simple, despite the way this might look. We'll put together an equation for each month, or each week, or for certain time periods, so we have a big set of equations. And the equation for each time period is, I will use the methods in this talk to calculate my total scope 1 and scope 2 emissions across all relevant facilities. That's on one side of the equation, E total. Then I will track the number of widgets of each type manufactured during the relevant time period, and I will multiply each of those numbers of widgets by a emissions factor that I don't yet know. That's my emissions per widget for that type of widget. And when I solve these equations simultaneously, I am solving for those emissions factors. Now, there's some variable overhead considered in this example. Those climate cooling degree days are the one variable overhead that we had to bring in and consider as part of the equation in order to get them to converge. And that's overhead from cooling facilities. So it's just looked at another widget. This approach is applicable in certain situations, not in others. It assumes a variation in product mix over the time periods for which we generate these equations. It requires modeling dynamic overhead, such as the cooling degree days, as one of the widgets. We need a lot more sample time periods than we have number of different widgets, but the benefits of the model are pretty substantial. And here's some results. This is taken from some real data over a period of about 2.5 years. There were about 3 or 4 widget types here. So we had, in total here, we had 30 samples, 3 or 4 widget types. The blue line are the actual emissions measured each month using the methods. There's scope 1 and scope 2 emissions measured each month using the methods described in the talk thus far. The red line are the modeled results. So once we solved the equations for the emissions factor per widget, we tried to use them. We took our manufacturing schedules from each month, multiplied the number of widgets of each type manufactured each month by the emissions factor, the emissions per widget number we came up with, totaled those products to get the red line. And as you can see, these track really closely. It took us about a year to train the system. We back applied it then for the purpose of generating this chart. But going forward, that model gets more and more robust over time, and any deviations alert us to changes in our process efficiency. And I invite anybody interested to be part of this. Okay, so with that, that's all I have today. It's been great to speak to you. I look forward to taking questions, and please feel free to reach out to me. There's my email address. Thank you.
Thank you, Yoram. Okay, as a reminder to all of our attendees, if you have a question, please do submit it into the Q&A box now. We do have a few here that came in, Yoram, so I will send one over to you now. You were talking about intensity. Can you share what intensity metrics should be used in your recommendation for manufacturers?
Yeah, well, I think it really depends on the context you're coming from, and often you may want to use several intensity metrics. So if your sole goal is to maximize revenue, and then of course your emissions intensity of interest would be emissions per dollar of revenue. But in many cases, you'll find that your intensity metrics might be widgets produced, which correlates with revenue, but probably isn't the same. They might be square foot a manufacturing facility. They might be number of employees. The intensity metrics you use will really vary from company to company based on your goals, and using several different intensity metrics will give you more insight.
Thank you. Okay, another question. What are your thoughts on PPAs, assuming this means the power purchase agreement? Good, bad, any ideas, thoughts on that?
They're great. I am not an expert on the different ways of buying energy. My colleagues at Environ Energy, that's what they do. Typically, a PPA is appropriate if you have a large amount of energy and you want to secure that energy at a certain rate with certain emissions. But I would recommend you reach out to me or to my colleagues at Environ Energy. I'd be happy to connect you with for further details on PPAs and RECs, and at least even direct lines.
Thank you. Okay, someone wants to know if they're looking for a software platform to start tracking their own emissions, start to wrap their heads around this, what features do you recommend they should be looking for in this emissions tracking software?
So a few of them. One is data integrity is pretty important. You want something to be able, garbage in, garbage out. So you want a platform that's going to kind of validate your data as it's coming in. You'll want to have sophisticated analytics. The whole point of this is being able to identify opportunities, hotspots, and then test changes in practices and see how they're impacting your results. So you want to have the ability to collect fine-grained data and to apply analytics, to frequently update the data, reapply the analytics, chart it, generate new tabular reports, get those numbers out, and learn what you can from them. You'll probably want a system that can help you model certain projects and forecast your emissions. You'll want all the output that you'll need to report emissions. Those are just some of the qualities I would look for in a software system.
Thank you. Okay, one last call for more questions. I actually have one for you, Jorn, since I read your description for the session many times. Can you explain what you mean by carbon being a proxy for waste?
Yeah, so um, it's it can be, if you're comparing, if you're considering swapping out a boiler from a gas powered, a fossil fuel powered boiler to an electricity boiler, um, there's no, how do you compare those two? There, one's using electricity, one's using some gallons or some amount of fossil fuel energy. How do you compare them? Well, you compare them in energy, but you can also compare them in carbon emissions. And it turns out that often you want to compare activities in terms of their efficiency, and the units just aren't comparable. But carbon emissions kind of give a common way to compare all different types of machines and activities. And that discipline of tracking carbon helps you identify where you're spending the most. Now, it's not always directly convertible to waste, but frequently that is the case.
Thank you for that.
Sure thing.
Okay, another question for you. In the context of electrification as a goal, what are your thoughts on fossil fuel intensive manufacturing equipment that doesn't currently have economically viable electrified technology?
Well, that's so case specific. So if it's if electrification is not an option, then of course try to harvest all the heat you can from that equipment and use it to drive generators for cogen so that you can power other machines with electricity. I'm not an expert on specific pieces of equipment and the time horizon for replacing them with electric equipment. I know that the electrification is a trend that we're seeing more and more of. So chances are, if there's no way to do it today, there will be in the future. So keep your fingers on that pulse.
And as you've shared today, it looks like there are some things that could be done in the meantime to mitigate what is a fossil fuel intensive, potentially equipment process, whatever it is.
Hmm. Yeah, like abating carbon capture.
Yep. Um, what is special about science-based targets? So you started mentioning that also within your presentation.
So science-based targets, there's a pretty regimented protocol around coming up with a science-based target. It starts with, in your industry, what are the emissions reductions required in order to keep global warming below a certain amount. So that protocol can be quite complicated, and you need to apply it to your industry and then get certified by the Science-Based Target Institute or get approved by the Science-Based Target Institute. And I think that targets are motivating and beneficial pursuit, whether you go to the trouble of getting them approved by the Science Based Target Institute. But it's really around getting them approved and meeting that protocol, meeting certain numbers. Oh, also, I don't think they recognize absolute intensity emissions as targets anymore. Whatever works for you, do something. Start somewhere. If intensity emissions are what work, start with intensity emissions. Right? Don't set yourself in an unachievable goal.
Uh, can you share some thoughts on when should someone use, or how common have you seen this, or is it even useful, the calculating alternate emission scenarios? Do you think that that might indicate risk greenwashing?
That's a
This,
really
this has come up a
interesting.
lot too at this current conference where I am right now, actually.
Yeah, I've gone back and forth on this. I heard a joke. Some kid comes home and says, Dad, I ran after the bus today. Instead of riding in it, I saved $2. And Dad goes, silly boy, you should have run after a taxi. It has saved a lot more, right? So, I mean, that kind of ridicules it, but I don't ridicule it at all. I think that if you are showing that you're reducing, if you're showing those alternate emissions and showing why and how you're reducing emissions relative to those scenarios, then you are engaging in the act of measuring and managing your emissions, and that's valuable. So, by all means, show the alternatives. Just don't stop there. Don't rest on your laurels with that.
So something is better than nothing,
Yeah,
as long as you intend to continue.
counterexamples are important.
Mhm.
That they point out good things you're doing. They point out the things that other people could be doing or other organizations could be doing. And they pull focus.
That makes sense. Okay, it looks like we have reached the end of our questions and we're almost at time anyway, only about 3 minutes left. So thank you so much for taking the time to share your expertise and your experience with us today, Yorm. Are there any final parting thoughts? What is the one piece of advice? I think I heard a few good nuggets in here. What is your one final piece of advice to all of our participants today?
Um, the philosopher around the turn of the millennium said, "It's not up to you to complete the task, but neither are you free to desist." So sometimes this seems like an overwhelming task here of kind of I come from a little bit of a bias of we're trying to save the world from climate change, and that seems can seem overwhelming, but just doing a little bit, just starting is hugely valuable. And so I encourage all to start. And as a bonus, you will identify ways to reduce waste and improve the bottom line.
Thank you. Sounds like something my mother would have said. A little bit, every little bit helps. Thank you
I
for
guess
your
that's a
time.
long way of saying that. Thank you, Anna. Thank you all.
Much more eloquent. Thank you all for your participation today. Thank you again, Yorm. And remember, we will be sharing the recording as well as the slides tomorrow. But in the meantime, if you have any questions, please reach out to either of the email addresses you see on your screen right now. With that, have a fantastic rest of your day. This now concludes our webinar. Thank you.
Thank you.